session 7, right? So we're actually more than halfway through the content, because there's 11 workshops of content. The 12th one is what we call exam readiness, which is where we talk about the registration, how to register for the exam, what you need to sit the exam remotely, and so forth. Okay, so we're just going to finish off a topic from yesterday that we didn't complete yesterday, and that is about infrastructure as code, right? So when we move into the cloud, basically there's more of a kind of emphasis put on automation of resource provisioning, right? So often we want to create machines when we need them. We want to turn them off, or even delete them when we don't need them. We're often using lots of smaller machines rather than fewer big machines. And of course, cloud is the financial model of cloud is very much an operational expense model rather than a capital expenditure model, right? So basically, when we're creating cloud resources, when we're learning, we're happy to do it through the console, right? Do it interactively through the console. But when we're creating cloud infrastructure in a production environment, generally speaking, well, almost always, we need to automate that process, or we need to script that process, right, of creating the infrastructure. So imagine you're deploying a new application that requires 10 virtual machines and 2 load balancers and 1 Kubernetes cluster and a couple of storage buckets. We want to script the creation of that infrastructure, right? Now, in Google Cloud, don't worry about the AWS and Azure tools, but in Google Cloud, we've got 2 cloud automation or cloud infrastructure as code tools. One is unique to Google Cloud, which is called Deployment Manager, and the other is Terraform. So Terraform is actually an open source product developed by a company called HashiCorp, and Terraform you can use to create resources on multiple clouds. So it supports multiple clouds, whereas Deployment Manager is unique to Google Cloud, right? So because of this, over the years of Google Cloud, Terraform has become popular amongst cloud engineers as the infrastructure as code tool, because if I learn Terraform, I can get some transference of skills between different cloud environments, because Terraform can be used to create Google Cloud resources, but can also create AWS resources, Azure resources, and so forth, right? So infrastructure as code is really the name given to that process of scripting the creation or update of cloud infrastructure, right? And as we said, it's not just building the infrastructure, though that's the most common thing we're doing. Equally, we might want to tear down the infrastructure when it's not in use. And infrastructure as code also plays a big part in our disaster recovery, because effectively, if our environment goes down in one region, we might need to recreate that environment in another region. Now, clearly, it's a lot easier to recreate an environment in another region if you have a script that you can just run, right? So typically, the scripts that we run in dev, test, prod, QA, whatever our staging areas are identical. They're just basically running in different environments, right? So that also helps us with disaster recovery, as we said, right? Okay, so this is what a deployment manager script looks like. So basically, in this example here, I want to create a virtual machine. Now, a virtual machine is one of the more complex pieces of infrastructure to create, because it's got a lot of properties. I've got to specify a zone, a machine type, an operating system image, a network interface, etc., etc. So don't get put off here that deployment manager YAML templates are really quite simple in structure, that they just have name, type, and properties. But the properties for a virtual machine are more complicated, right? So it just happens that the example here is more complicated. If I was choosing a simpler object like a subnet or something like that, I might only have a few properties, but with virtual machines, I have a lot, right? Okay, and basically I can either I can create deployment manager templates. So once I've coded my YAML, then I can create the deployment with my G-Cloud Deployment Manager deployment create command, give the deployment a name, and specify the configuration file in which my deployment details are specified, right? I can list all my active deployments, I can update an existing deployment, and I can delete it with the appropriate commands. Okay, now Terraform, on the other hand, as we said, supports multi-cloud environments. Deployment Manager is unique to Google Cloud, right? So over the years, Terraform has become the preferred infrastructure as code tool. And actually, in your learning path, you'll see that you've got a number of labs at the end of Module 6, which are about Terraform, right? I'm not even sure you're doing a deployment manager lab in your learning path, right? There might be one, but generally the emphasis now is on Terraform, right? And with Terraform, it supports multiple providers, so I get the transfer of skills, but in concept, it's not dissimilar to Deployment Manager. So again, here I'm creating a resource, and again, you can see it's a compute engine instance. So once again, I have to specify a lot of those properties: name, machine type, zone, network tags, boot disk, etc., etc. Right? So this is a script to create a virtual machine according to my specifications. Okay, now Terraform, when I'm running a Terraform commands, first of all, I have to initialize the Terraform environment, but I've also got this distinction between plan and apply, right? So when I run the Terraform plan command, what it will do is it will look at my Terraform source code, see if there's any errors, but it will also tell me what it's going to do without actually going ahead and doing it. So imagine I'm deploying a new application and I've got a Terraform script to create 10 virtual machines, update a Kubernetes cluster, and update a SQL database, right? So I've got all of that in my script. So when I run the plan, assuming that I don't have any syntactical errors, the plan will tell me this is what I'm going to do. I'm going to create those 10 virtual machines, update that cluster, and update that database. But it won't actually do it, right? So the purpose of the plan is that you can review what is going to happen before it happens, right? Now, once you're happy with it, then you can apply the update, right? But again, it basically plan says, this is what I'm going to do. Apply says, okay, go ahead and do it, right? So you get a chance to review what's going to happen before it happens. Right? Okay, and Google Cloud also make available some code templates that reflect best practices. And these are available for both Deployment Manager and Terraform. And again, they're called Cloud Foundation Toolkit. So again, if you just look for that, and it will link you to modules that can help you get started, right? So basically, if we click on that, So again, these are ready-made templates for Deployment Manager and Terraform. And again, if we go and look at the documentation, you can see that you've got different you've got different templates for different types of resources. So depending what type of resources you want. So let's just say that we want to create. So again, you can see here we've got different types of resources. So again, if we click on this one here, it's taking us to the GitHub repository where we can find that example source code. And again, we have both Terraform and Deployment Manager examples, right? So as with any kind of coding, you never want to kind of start from a blank slate. You always want to find templates which illustrate best practices and can get you started quickly. So that's what Cloud Foundation Toolkit is designed to do. Right? Okay, and again, the last thing that we're going to talk about relating to infrastructure as code is config connector, right? So what this allows you to do is it allows you to define your Google Cloud resources in the same way that you would with if they were Kubernetes resources, right? So Kubernetes has a concept called a custom resource definition, which again, we don't need to go into, but basically it's a way of customizing Kubernetes resources. So the appeal of config connector is that if my cloud administrators are more comfortable with the Kubernetes resource definitions, they can define their Google Cloud resources in the same way they would manage their Kubernetes resources, using YAML files and then applying the YAML files. So here I've defined a pub sub topic and called my pub sub topic, and then I'm going to do kubectl apply as if it was a Kubernetes resource. Right? Okay, so just mention that in passing. And that's just finishing off module 3, right? So now we're going to start our topic for today, which is storage and database options. So again, this is now in module 4. If you're following along in your PDFs, so remember. You all have your purple box, hopefully. And if I go into module 4, and again, I can download that. But once you get past that normal kind of preamble and stuff, you'll see this is where we are. So we're now in module 4. As I said, if you're following it along, right? So let's just get rid of module 3. We've done that one, and we'll go with module 4. So now we're going to talk about the different storage and database options in Google Cloud, right? And what we're trying to do here is we're trying to know enough about each of the storage and database options to know when we would use them and do some very basic configuration of them. We don't need to be experts in all these technologies. We just kind of need to know when when we would choose, say, Cloud SQL rather than BigQuery, or when we would choose Spanner rather than Bigtable or whatever, right? So when would we choose regional disk versus zonal disk and so on, right? So planning and configuring is like choosing the right product for the right use case. Then we've got a little bit on how do we kind of initially set up the system. So how do we create a Cloud SQL instance? How do we set up BigQuery? In fact, BigQuery almost needs no setup. We're just good to go with it, and so on, right? And also how we load data. And then there's also some stuff around cloud storage, object lifecycle management, securing objects and so on that we're going to look at as we go through. Okay, so the first thing we're going to talk about is Google Cloud Storage. Now, remembering that we talked about block storage, which is persistent disk, and file store in an earlier module, right, back in module 1, right? So what we're going to do now is talk about cloud storage, right? And so cloud storage is basically works off an object storage metaphor, and it's good for storing unstructured data, right? So what do we mean by unstructured data? Well, basically, if we go into our project, well, probably the easiest thing to do, unstructured data is best understood by understanding what is structured data, right? So structured data the structured data is generally in tabular form and has a schema, right? And again, we'll talk about what a schema is and so examples are databases, relational databases, or data warehouses, right? So both of those things use structured data. Unstructured data is things like images, videos, sound files, documents, etc. And again, an example of that is store it in cloud storage. Right? And basically, there is no schema. Right? So schema tells you the structure of the data. So if it doesn't have any schema, well, it's unstructured, right? So let's look at structured data. And we can, for example, look in BigQuery because data warehouses use structured data, right? So if I go into BigQuery and basically I go in and have a look at some of my tables that I've created. So as I said, I think I showed you, I've got details about the IPL, every ball bowled in the IPL between 2008, 2020. But this is a schema, right? So when I'm talking about data warehouses or databases, I have a schema. This tells me the structure of the table. So it tells me all the columns and what type of data is in the columns, right? So when I click on preview, I can see that data, right? But the data is in tabular form, it's structured, and I have a schema. So that is very typical of data warehouses and relational databases, right? But if I go and have a look in my cloud storage, so if I go and have a look in my buckets, say, so these are all my buckets that I've got. And let's just choose the first one. And basically there's a whole bunch of objects in that bucket. But again, all those objects have different structures. Some of them are JPEG files, some of them are text files, some of them are CSV files, PNG files. They're all different from one another. So there's no common structure to the data, right? They're unstructured. But cloud storage is a very good storage option for unstructured data, whereas structured data, it's more for databases, relational databases, and data warehouses. And again, you can check out the sketch note for cloud storage, but we're going to talk about some of those capabilities. Now, again, the other thing is cloud storage is fully managed, right? So what we mean by that is I could upload millions of objects into my bucket, but I don't have to manage the storage. In other words, I don't have to check there's enough space in my bucket because my bucket is potentially infinite in terms of its size, right? I can just keep loading objects and the storage will automatically be managed for me automatically, right? So that's what we mean by fully managed. There's nothing you as a customer need to do with cloud storage in terms of, you don't size a bucket, for example. I mean, you size a persistent disk because that is not fully managed, but you don't size a bucket. You just create a bucket and start uploading objects into it. Right? Okay, so basically we talked about how buckets basically contain objects. And basically we also, if you look carefully at all these objects in the bucket, they all have a storage class, right? Now, a storage class will determine the pricing or how much I am charged for storing the object. It does not affect the functionality, right? So different objects can have different storage classes in the same bucket. So you see this one is standard, this one is nearline, and so on. So again, to reiterate, the only purpose of the storage class is to affect the pricing of the storage. It doesn't affect the functionality, right, in any substantial way, right? So what you're trying to do with the storage class is you are trying to set the storage class that matches the access requirement of that object, right? So if the object is accessed frequently, like more than once a month, then standard storage class is your best bet. If it's accessed once a month or nearline is your best bet. Less than once a quarter, you can use the cold line storage class. Or for long-term retention for data that's rarely accessed, you can use archive, right? So by matching the storage class to the access requirements, you will optimize your storage costs, right? But as I said, the functionality of the storage classes is virtually identical. Okay, so as we said, with cloud storage, we do not need to provision storage in advance. We just use it, right? So we pay for what we use, not what we allocate. This is different from persistent disk. With persistent disk, if you create a disk of, say, 100 gig, but you only use 50 gig of space on the disk, you still pay for 100 gig because you allocated a 100 gig disk, right? But with cloud storage, because you don't have to provision capacity in advance, you just pay for what you use. And the data is automatically encrypted, and I can access the data with HTTPS, right? So if I go back and look at my objects, so you see this one is public access here. So you see here, if I look here, here's the public URL. If I just copy that and put it in a new tab, because it's public access, I can access the thing through HTTP. Okay, so just pause there. Yes, so the question is, do all storage types have the same encryption and security features? Yes, they do, right? So the storage type does not impact the encryption and security options available, right? Okay. So we talked about those features. Okay, now the other thing is, first thing we have to decide when we create a storage bucket is, where is that bucket going to be? Now, normally we want to store our data close to the point of usage, right? So if our application is deployed in US Central, we would generally deploy our buckets in US Central as well, right? To make for the most efficient access. So when I create a bucket, you'll see, again, I have to give a unique name for my bucket. Again, that has to be globally unique, not just unique within the project. And so once I've done that, then I have to choose where my bucket will be, right? Now, normally by default, I would choose my bucket to be in a single region, because that will give me the lowest latency, right? But if I want higher availability, I can choose either dual region or multi-region. Now, again, if you look at the cost here, you'll see that the cost of regional is 2 cents per gig per month. Multi-region is a little bit more expensive, right? Because I'm storing the data in multiple regions. So you might say, why should I pay that extra? Well, because then I will have the highest availability. Because if my data is in a single region and that region becomes unavailable, then I can't access my data. But if it's multi-region, I can, right? So if you look at the Google Cloud Storage service level agreement, so basically a service level agreement is Google's contract with their customers about availability, you'll see that the regional storage is 99.9% is the service level objective, right, per month, right? But with multi-region and dual region, it's a little bit higher, right? So if you want the highest availability, you can go with multi-region or dual region, but that does give you more cost, right? So it's a trade-off between higher availability and higher cost. Again, very familiar trade-off for architects. Okay, so we choose where we want our storage to be. And we also talked about the storage class before, how we want to optimize the storage class based on the access requirement of the object. Right? Okay, so next thing we're going to talk about is how do we get data into Google Cloud, right? So and again, normally when we're moving data into Google Cloud, the staging area or where we land the data is in cloud storage, right? Now, if it's, if I've just got a small amount of data, I can, of course, just upload it directly, right? So I can do like so. Oh, actually, that object is already there. So sorry. I'll just cancel that. But, if it's a small amount of data, you can upload it directly via the command or via the console, right? But what about if you have larger amounts of data, right? Then you have other options, right? So the first option is storage transfer service, right? So storage transfer service is a bucket to bucket transfer, right? So again, if we just bring that up. So this would be a good option if I was moving my data from another public cloud or even an on-prem environment, right? So basically, I can create a transfer job. Now, I can use this to move data between Google Cloud buckets, but not if I want to bring data into Google Cloud, it's generally somewhere else, right? So it could be in another cloud, right? It could be in this other cloud. It could be on-prem or on another URL, right? So I can actually use the storage transfer service for bucket to bucket transfer. Now, again, because I don't have an account at those other cloud providers, I'll just show you bucket to bucket, but as I say, I can move it from other buckets, right? Then I can choose which bucket I'm moving it from and what the target bucket is. So let's say it's that one. And then I can choose, is this just a one-off job or do I want to run it regularly? And then I can choose my settings, which handles things like, well, how do I want to handle the existing permissions? How do I want to retain the existing encryption settings, storage classes, etc. Right? So basically I can specify how those things are handled. Then I can create the job and that will run the job, right? So that is one option, the bucket to bucket transfer, right? Is storage transfer, right? Now, if I have huge amounts of data, then I can use a transfer appliance, which is effectively an offline import, right? So with a transfer appliance, I basically request one of these devices. I say to Google, send me one of these devices, right, to my on-prem environment. I will rack up that device. I will copy my data to it. I will ship it back to you, and you will then copy it into my Google Cloud project. Right? Now, if we look at the specifications, these basically, you'll see we've got different types of devices, but if we look at the high-end one, this can take up to 300 terabytes of data. So, I can move a lot of data at one time, right, with the transfer appliances. So think of transfer appliances as an offline import that I can use, right? Now, you might say, well, why would I do that? Well, if I'm moving, and again, typical company is moving, petabyte of data. Let's say they're moving 1 petabyte of data and they've only got a 1 gig link to copy it across. That's going to take them more than 4 months to copy all that data. So it's actually quicker to do an offline import.